Alright guys, today we're going to look at section 4.7, which is inverse trig functions. Okay? So, I want to tell you that there are three inverse trig functions we're going to look at. The inverse of sine, the inverse of cosine, and the inverse of tangent. And his interval is negative pi over 2 to pi over 2. So that's where his domain is lying. Cosine's domain is from 0 to pi. And inverse tangent is negative pi over 2 and pi over 2. Okay, and I'm going to show you, if we would look at the sine graph, why this happens. Okay, so I'm just going to do a quick sketch of the sine graph. So we know that the sine graph has a period of 2 pi. So if I cut that into its 4 pieces, just like we did in 2 sections ago, we know sine starts at 0, goes to 1, back to 0, negative 1. Now, what's going on here at 0 and at pi? Okay, and I'm actually going to extend it just a little bit further so you can see the negative pi over 2. Okay, these things, and I wish I had a highlighter, but it's across the room. Let me extend my curve a little bit further. We're going to isolate this unit, again, so that I can prove that it has an inverse function, right? Because remember the horizontal line test, that if you drug your horizontal line across and it hit at only one point, it had a inverse function. Do you see, if I didn't limit it, or if I limited it here, it would not have an inverse function. Alright, so that's why it has those limitations. Okay? Likewise, let's look at cosine's curve. So again, cosine has a period of 2 pi. And cosine begins at 1 and looks something like that. So again, if I were to look at this range, or this domain, it would fail to have an inverse function. So if I limit it to just there, between 0 and pi, I get that it truly can have an inverse. And tangent would work the same way. So let me just do a quick sketch of tangent. So remember, tangent goes from negative pi over 2 to pi over 2. And tangent starts low and goes high. So again, if I did the horizontal line test, he would have one. Alright? Okay, so let's go ahead and jump right into example 1. And I am going to get you guys to get your calculators handy and your trig help sheets. Find the exact value of each. I want the inverse sine of square root of 3 over 2. Alright, so let's start with our trig help sheet. Now, this one's going to be a little bit backwards. First thing I need you to do is figure out what quadrant you're in. So notice sine is positive. Well, the inverse sine only exists in these 2 quadrants here. Okay? Because it goes from negative pi over 2 to pi over 2. So in which of those quadrants is sine positive? Quadrant 1. So I know I am in quadrant 1. So I'm going to go ahead and do a quick write down that I'm in quadrant 1. Alrighty? Now, these you're going to work backwards. You're going to go to sine and find your square root of 3 over 2 and come across to get your angle. Because I'm in quadrant 1, I know that I am truly pi over 3. So today you're sort of working backwards. What you need to do, and you might want to write it up here, is that the inverse sine exists in quadrants 1 and 4. the inverse cosine exists between 0 and pi, so it exists in 1 and 2, and the inverse tangent also exists just like sine in 1 and 4. Okay? So in other words, there is no inverse cosine down here. Alright, let's use that information to try a few more. What if I want the inverse sine of negative square root of 2 over 2? So the first thing I need to determine is what quadrant I'm in. So again, I look up here at the inverse sine, and I know I have to be in one of these quadrants. Which of those quadrants is sine negative? Sine is negative in quadrant 4. So I know I'm in quadrant 4. So let's go to our chart, find sine square root of 2 over 2, and I have to be a pi over 4 angle. But I need to be in this quadrant. So you could tell me I'm 7 pi over 4, but if you did that, I'd have to go all the way around. What's a quicker way to get there? Negative pi over 4. And, you know, again, we're pretty lazy as mathematicians, so I want you to tell me the most efficient way to get someplace. Alright, let's do the cosine, inverse cosine of 1/2. I'm going to see if I can unzoom just a little bit because I want to be able to look up here the whole time. So, inverse cosine is in quadrant 1 and quadrant 2. My question is, I need it to be positive. Therefore, I must be in quadrant 1. So I come here, and I need to find a cosine of 1/2. So cosine of 1/2 is right here, so I must be at pi over 3. When they're in quadrant 1, it's nice. You don't have to do a lot of thinking. So when they lie in these other quadrants, that we got issues. Alright, let's try 2 more. Let's do an inverse cosine of negative square root of 3 over 2. And then I'm going to do the tangent, the inverse tangent of negative 1. So what I'd like you to do is go up to the top of your page where you have your quadrants drawn and decide what quadrant do you need to be in if you're taking the inverse cosine of a negative. So you knew you were in one of these quadrants, and if cosine is negative, you must be in quadrant 2. So we're going to have to do a little bit of work. So I need you to come to your chart, find cosine, square root of 3 over 2, you must be pi over 6. But you are in quadrant 2. Now, is it quicker to go 5 pi over 6 or to go this long way? It's quicker just to go 5 pi over 6. Alright, and I'm going to see if you can get this last one all by yourself, and I'm going to go grab my calculator. Alright, so let's take a quick look. Hopefully you determined that you were in quadrant 4. You came to your little sheet. You found tangent of 1 happened at pi over 4. So you are down here. The quickest way to get there is to go negative pi over 4. So how'd you do? Hopefully you did great, and now we're ready to move on to the next thing. Alright, so grab your calculators. And I need you to make sure this time that your calculator is in radians. So I'm not sure that you can see with that doggone glare. There it is. So go back to mode, press your mode button, arrow down right there to where it says radian or degree. Right now your degree is highlighted, highlight radian. Okay? Alright, example 2. Use a calculator to find the value round to the nearest 10,000. Alrighty, so grab your calculator, and you're going to want to press to get your cosine -1. Do you see right above the cosine button? Okay, here's cosine. Right above it is cosine -1. You're going to want to hit your second button. So hit second cosine, and then type 1 divided by 3. Okay, and again, let me see if I can arrange this so that we get the glare off of it. And there I go. So it's 1.2310. Let me write that in a different color. 1.2310. And now try the same thing. Hit shift tangent, -35.85. And were you able to get -1.5429? Okay, so far so good. Let's look at the inverse properties. If I take the sine of the inverse sine of x, I get x. Likewise, remember we did inverse properties back in chapter 1. We said if you put f of x and g of x and solve it, you should get x. And if you put g of x and f of x, you should get x. So that's really all we're saying here. Likewise, if I take the inverse sine of the sine of x, I still get x. Now what's interesting is their domains are going to be a little bit wacky for you. This is going to be from -1 to 1, right? Because sine oscillates between -1 and +1. The inverse sine, however, oscillates between -π/2 and π/2. Okay? Let's talk about the same thing with cosine. So I can take the cosine of the inverse cosine, and I still get x. And what does cosine, what is his range? From -1 to +1. And if I take the inverse cosine of the cosine, I again get x. But his limitations, again, are from 0 to pi. And lastly, we'll write down the tangent. So if I take the tangent of the inverse tangent, I get x. Tangent is all real numbers. And then if I take the inverse tangent of the tangent, I get x. And he has limitations of -π/2 and π/2. Alright, you ready? Oh, sorry about that. One of these days I'm actually going to bring in that WD-40, and then that chair won't squeak anymore. And then you won't even be able to wake yourself up. Okay, let's see. Example 3. Find the exact value if possible. So what you're going to have to do to tell if it's possible or not is you're going to need to come up here and match it with its inverse property. So I'm taking the cosine of the inverse cosine. The cosine of the inverse cosine, I need my number to be between -1 and +1. Is it? Yes, 0.7 is in that range. So now these will cancel each other out, and I just get 0.7. Now, I don't need you to memorize this. I'm going to make sure that you have that information. Okay, let's say I take the inverse sine of the sine of pi. Okay? Now, this one's a little bit tricky. It originally looks like you would say no, because you go up here and you say, hey, pi isn't in that range. This one is super tricky. First of all, what is the sign of pi? If you look at your chart, you know the sign of pi is 0. Now, does that fit in my range? Yes, it does. So even though at first glance it looks like this doesn't exist, it really does. And what is the inverse sign of 0? If you need to, type it into your calculator and you'll get 0. And if you're, struggling with that one a little bit, he is tricky. We can go ahead and talk about that tomorrow in class when you practice these. Alright, let's talk about taking the inverse cosine of negative 1.2. So this time I don't know what the inverse cosine of negative 1.2 is. In fact, if you try to take the inverse cosine of negative 1.2, what does your calculator say? It has a domain issue. So this is not valid, or not possible, or whatever you want to do. Okay, questions? Well, not like you could ask them anyway. Alright, so the last thing I'm going to want to do with you real quick is at least talk about how to find the exact value. And we'll probably have to pick up with this tomorrow. Alright, example 4. Find the exact value for each. Let's say I want to take the sine of the inverse tangent of 3/4. We're going to go ahead and draw our little triangle in the quadrant. So the first thing I need to do is determine where is the tangent of 3/4. Well, I know that the inverse tangent only exists in quadrant 1 and quadrant 4, and this is positive, so it must be in quadrant 1. Remember, we go left, right, up, down, make our triangle. There's theta. Now, tangent is what? Tangent is O over A. So opposite theta, I'll put a 3. Adjacent to theta, I'll put a 4. And now I know that has to be 5, right? Because x squared equals 3 squared plus 4 squared. So now I'm really saying, what is the sine of this angle? Well, come over here, label your O, your A, and your H. So sine would be O and H, right? SOHCAHTOA. So O and H, my final answer is just 3/5. Okay? I think I'm going to try one more of those, and then that just leaves us one example to do tomorrow. Actually, you know what? I don't think I'm going to push us, so let's just go ahead and we'll pick up with one of those tomorrow. You guys have a great evening.